predefined to English. I think we have a seat left here. No, we haven't. Okay. So I will start. We're just a minute to go. So welcome to the session Cluster Sets in Windows Server 2016. What is it and why should I use it? My name is Carsten Rachfal. I'm MVP from Germany, now in my 8th year. I started as a virtual machine MVP, then Hyper-V MVP, and now I'm in the infrastructure group called Cloud and Data Center Management. And there you find cluster MVPs, storage MVPs, Hyper-V MVPs, and cluster set has to do with all of those categories. So let's start. What are cluster sets? So if you think about multiple clusters, and here in this slide we see four node clusters, and let's assume there are hyper-converged storage spaces direct clusters. So who of you knows storage spaces direct? Fantastic. So storage spaces direct, you can have your storage system in the cluster and also run your virtual machines on the same machines. And in storage spaces direct, when we have a 4-node cluster and you have the right resiliency, you can lose 2 nodes. Okay? We could also form of these 16 nodes one large storage spaces direct cluster with 16 nodes, and we would get more space for our data, but the resiliency would be also you can lose 2 nodes. So with cluster sets, for example, we can create 4 of those clusters with 4 nodes each. In each cluster, we can lose 2 of them and build a cluster of clusters, so we can move around the virtual machines like we could do in a large cluster with 60 nodes. So we gain resiliency and don't lose the mobility of the virtual machines. So let's look how the cluster sets are working. So we have our 4 node S2D clusters, hyper-converged, and we create a new cluster, a cluster set cluster, that has to have at least 2 nodes. And that can be on hardware, or it can also be in virtual machines. It doesn't matter. It's just something that cares about the cluster set. Yeah, if you have hardware, great. Place it in different fault domains, maybe. Yeah, if you do it in virtual machines, you should put maybe 1 virtual machine on this cluster and another of the cluster set in another cluster. And you can have more. You can have 3, 4. It's a cluster with a file server on it. And when we create this cluster set cluster or the master cluster, we get a unified namespace. So in this example, you see here, / cluster set / share. What a cluster set offers us is a UNC path to the VMs. So if you are familiar with an hyper-converged storage spaces direct cluster, the data is stored in CSV, so cluster shared volumes, and cluster shared volumes have the path C:/ cluster storage / volume, and then there are your VMs. It's the same way if you have a SAN storage under a cluster, you also use CSVs, you have the same concept. So now we form our cluster set, and I have some slides about that, and get our unified namespace. In essence, on this host we will install an infrastructure scale-out file server. That's a new role in Windows Server 2019. So in 2016, you can't put a file server on a hyper-converged storage spaces direct cluster. If you put Hyper-V there, the file server role is not supported. And there are some issues with that. Now we install the file server with a special role, the infrastructure scale-out file server. And all our volumes under C:\/ cluster storage / volume 1, 2, 3, however, are now reachable through an UNC path. In this cluster is unique. The UNC path is unique to this cluster. This has another UNC path, this has another one, and this has another one. And then we put our cluster in the cluster set, and we reach all of those volumes and the virtual machines in there over one unified UNC path. So, great thing, I talked about that already. Here in the 4-node clusters, we have a resiliency of, we can have a failure of 2 nodes. Now we have 16 nodes in our cluster set. We can place a lot of more VMs on it, but we have still the same resiliency. Every cluster can lose 2 of the nodes. And that's much better than in a 16-node cluster. Yeah? So some cluster benefits, combining multiple small clusters in a single large fabric without sacrificing resiliency. That's very important. You have still great resiliency there. We can manage the failover cluster lifecycle without impacting running VMs. What does that mean? So if you have a cluster set, let's assume we are 2 or 3 years ahead. You build your cluster set and you want to extend your cluster, or you have an old cluster that you want to replace. You can add another new cluster to your cluster set. You set up storage bases direct on that, hyper-converged, for example. You add this cluster to the cluster set. You move all your workloads from the cluster you want to remove to the other cluster nodes, and then you can remove your cluster from the cluster set. So that's a possibility to replace an old cluster with a new one. In Azure, we have fault domains and availability sets. You get that with cluster sets too. You can create fault domains. For example, you remember the 4 clusters. Let's say cluster 1 and 2 are in room 1, and cluster 3 and 4 are in room 2. So you can create 2 fault domains, room 1, room 2, and then you can create an availability set of the 2 fault domains. And if you have applications that have multiple virtual machines, let's think about SharePoint or so, you can place them in the availability set, and one VM will be placed in room 1, and one will be placed in room 2. So if you have a failure in your fault domain, room 1 is gone, power loss, whatever, the other VM is in the other fault domain, and your application is still working. So we have the same in Azure, and get that now also in Windows Server. When we add a new cluster, let's say after 2 years, to your cluster set, or you want to extend your S2D nodes, in 2 years you won't get the same hardware from your OEM. Because every year there's a new hardware cycle, you get new machines, and it's very hard after 2 or 3 years to get the same machine. Yeah? In a cluster, you should have the same hardware. Now with cluster sets, we can create a new cluster, maybe a 2-node S2D cluster, and then move our virtual machines. Of course, we have to, if we have different CPUs, processors, of course, we have to enable the processor compatibility in Hyper-V, but then we can move the resources between the machines. So some PowerShell for you when we create a cluster set. So to create the cluster set, the master cluster, there is a new cluster set commandlet where you specify the name of the master cluster, how your unified namespace is called, the share, and so on. Then, when you created that, you can add your clusters, the 4 different clusters, we can add them to the cluster set. We can also, we don't have to, but we can create fault domains. Remember room 1, room 2, we would say cluster 1 is in fault domain room 1, cluster 2 is in fault domain room 1, 3 and 4 is in fault domain room 2. And we can also create cluster set availability sets. And when we then use them with our virtual machines, the cluster set cares about placing the VMs in different fault domains. I have some animation about how the placement works. First, the PowerShell commands for the placement or the VM handling. So if you want to create a new VM, you want to know where it's best to place it. So you have your 4 clusters. You ask your cluster set with the command that get cluster set optimal node for VM, very long but self-explaining. You tell him it has 4 gigabytes or 8 gigabytes, how much memory the VM needs, how much processors you want to have the VM to have. And then it tells you, oh, node 4 of cluster 3. Then you create your virtual machine there with the normal PowerShell commands like new VM on that node, create it, install your operating system. And after that, you register the VM in the cluster set. Then the cluster set knows this VM. So you can have VMs that are not registered in the cluster set in those clusters, and you can have VMs registered in the cluster set. And then there's a time where you maybe want to move the execution of a VM from one cluster, base cluster, to another cluster. And because we have our UNC paths and we have SMB3, we can now do that. We can move a VM that is in cluster 1 with live migration to cluster 3. The data is still on a CSV in cluster 1. So you can move your virtual machines around, but the data stays where it was. It will not also move to cluster 3. That's possible. We have the storage migration for that, but you only, in a cluster set, you usually only move the virtual machine. Yeah? If you want to destroy a cluster, to get it out of the cluster set, of course, you have to move all the data from the VMs, from the local CSVs to another cluster node. That's also possible with a storage, move storage command. Something like that, I'm not quite remembering. But there's a PowerShell command for that to move the data. But that takes time because he's really copying the data of the VM. So imagine a 50 gigabyte machine with a disk of 50 gigabyte, it takes some time. Imagine a 500 gigabyte VM, it takes much longer, 10 times longer. So that is a process that takes time. It depends on your network, how much bandwidth you have between the nodes, but you can also move the data. You can also, there's a PowerShell commandlet where you can ask the cluster set, which virtual machines do you know and where are they running? I have a small video about that where you can see that. So here again we have our picture and how the cluster set places VM. So we ask the cluster set where to place a VM. It will tell us cluster 1 is the best, or even node 1 in cluster 1 is the best. Then you create the VM there and register it in the cluster. When we create another VM, we ask him again, and he will tell us in this example, oh, now in cluster 2, node 1 is the best place for a new VM. And we can also move the VM. So this animation is not quite correct. We move the VM from 2 to 3 with a live migration, move cluster set VM, and it will move the execution of the VM to another cluster, but the data stays in cluster 2. That's possible with a cluster set. And I told you before, to use that feature, we have to install the infrastructure scale-out file server in every cluster, and then we get the UNC paths, and with the unified namespace, the unique UNC path of every cluster is then unified to a UNC path for the whole cluster set, and we can just place our VM here, and it will we can then specify the different volumes on the cluster. And this is possible because now Windows Server 2019 supports the SMB loopback mode. That was a problem if you install storage spaces direct, hyper-converged with Hyper-V, and also put the file server on the same box. Hyper-V, when it runs locally, needs the path C, /, cluster storage, and so on, the CSV path. And when you use / share name, it will not work in 2016. With the loopback mode in 2019, it will work. So that's a great new feature here. So I have a small video where we can see how a virtual machine is moved. So I start. First, we ask the cluster set about all the virtual machines that are registered. And here we see in our, it's a very small cluster. It's only 2 clusters. One is named CS Work and the other is named Class Hype. So we have 3 virtual machines running in these 2 clusters. CS underscore VM1 is, and VM2 are running on CS Work, and VM3 is running on the Class Hype. So now let's have a look. Oops, sorry. Wrong key. Now let's have a look in the failover cluster manager where you see all 3 clusters. Our master cluster here. Then we see our CS Work cluster and the Hype cluster. Here's 1 VM, and here you see the infrastructure file server role. It's running, and here we see the other cluster with the 2 VMs running. Now we go back to PowerShell. Here's a commandlet that will move the VM CS underscore VM1 to node class hype 1 - 2. So we have to specify the node in the cluster where we want to move the VM. And it's now executing. Now it's doing a live migration from one cluster into another cluster. And that's not possible before that. Live migration is bound to a cluster. There is a possibility to get a virtual machine from one cluster to another. Virtual Machine Manager does that. But in essence, you have to remove the role from the cluster, then do a shared nothing live migration, including the data from one cluster to another, and then register the VM in that cluster. That is the way you can do now. And with 2019, you can use cluster sets to get more fluidity for your virtual machines. And now after the move, we did another get cluster set VM, and we see now that our CS underscore VM1 is now running in the other cluster. Remember, the data are still in CS Work. So if you shut down CS Work, the whole cluster, you should not do that, but if you do that, the VM can't run anymore because the data is still in that cluster. So if you want to know more about cluster set, there is already documentation at docs.microsoft.com. Just search for cluster sets Microsoft, you will find that page. There are also example, PowerShell example, how you create a cluster set and how you leverage the different commands and move VMs around. You can do that. And that's the end of my presentation. I'm quite on time. I have just a minute left. Please evaluate the presentation. And if you have questions, please come to me here to the side, and I try to answer all your questions. Thank you very much for attending, and I hope you have fun this evening at the party. Thank you.